All right, science. Okay, we're going to finish talking about solutions today. So, as a reminder, make sure you have the textbook scan so you can follow along, and then I'll be walking you through the PowerPoint slides and reading the textbook in this video. And then just like yesterday in the part 2 video, we'll be doing the workbook pages together. All right, ready to go? So as a reminder, we got these two nice GIFs over here reminding us what a solution is. Remember, we have 3 parts of a solution. So just a quick review. The solute is the substance that is dissolved. So for example, salt, sugar. The solvent is the liquid. Not always the liquid, but solvent is the substance that dissolves the solute, the other substance. So the most common solvent in the world is water, right? The universal solvent. And when you combine the solute and solvent together, it becomes a solution right over here. The interesting blue liquid over here. Okay, cool. So let's move on. We're going to be talking about what happens if you put too much solute into the solvent, and what happens if you don't put enough solute into the solvent. So the first word to know is concentration. What is a concentration of a solution? This is basically the amount of solute that is dissolved inside the solvent. In other words, it's, for example, how much sugar do we put inside the water? Or how much salt do we put inside the water? So for example, the solute over here, we have some sugar cubes. The solvent is the water. The more you put it, it's probably gonna get sweeter. And the less sugar you put, it'll be less sweet. So in other words, we have like a different, there's like a spectrum of what would happen. So look at this picture over here. Diluted is basically the lightest color. They put the least amount of food coloring, so it's kind of pinkish, right? But then as you go through the scale, it gets darker and darker and darker, and it becomes more concentrated. So it becomes darker. The color becomes darker because they put more of the red liquid inside the water. Another example is the salt water example. Dilute, again, it's the least amount of solute that is inside the solvent. So it's the little bit of salt, just a little sprinkle of salt, okay? Not very salty, but concentrated. It's a lot darker, right? Because we put a lot of salt. So again, diluted is the least amount. And the more you put, the more concentrated it becomes. I hope that makes sense. So let's look at the difference between these two liquids. So we got like a lighter looking orange juice and then a darker looking orange juice. Or maybe this is carrot juice. Yeah, so as you can see, which cup would be diluted and which cup would you say is more concentrated? Excuse me. Diluted, if you said the first one, you are correct. So this one is more diluted and the other cup is concentrated because there is clearly a lot more solute inside the solvent. All right, so we got diluted and we got concentrated. Believe it or not, it can get even more concentrated. So diluted is the lightest end. The darkest end is actually called saturated. The darkest it can get. So saturated means the solvent, it's like the water, is literally holding all of the solute that it can dissolve. Like it can't dissolve anymore. So it happens if you add more and more and more and more salt into the water, more sugar into the water, and becomes so dark and saturated, like there's just no way that it will dissolve anymore. So for example, this is a really good example with tea bags. So I don't know if you guys like tea, like green tea. I actually had tea this morning. Oh, it's right here. Yay! So I got my tea here, correct? So right now this tea bag has been in this water for I think almost 20 minutes. So I hope I don't spill this in the computer, but you see how it's kind of really dark in there? It's extremely saturated because it's not going to get any darker than this, guys. So it has reached its limit. The water cannot dissolve it anymore. But if I just put it really lightly, so here is just normal water. And if I moved to like a mini science experiment, can you see it? Okay. So again, this is like the extremely saturated tea. If I remove this tea bag and put it in this water, it's gonna be a lot less concentrated. So you see how it's like really clear? So this is diluted and this is concentrated. Actually, it's so concentrated that it's actually saturated now. Yeah, that's extremely saturated. Wow. Okay. So I hope that makes sense. Now we're gonna kind of switch gears into how fast can a solute even dissolve? The rate of the solute. So we got these delicious looking sugar cubes over here. So how fast can it dissolve? So remember, dissolving is when the substances separate and spread out and it looks like it's disappearing. How fast can it dissolve? Well, you can increase the surface area by crushing the sugar cube. We can all agree that if we put a sugar cube into water and then we put crushed sugar into the water, the crushed sugar will probably dissolve faster, right? That's why if you wanted to make it dissolve faster, we'll crush it or crumble it or just cut it up into small pieces because that way it'll dissolve faster. Or you can just stir it, right? I know it says Starbucks here, but that's not me. But you can just stir it. So for example, if you put sugar in your coffee or if your mom and dad put sugar in their coffee and they'll stir it because that way it will dissolve faster. So how can we make it dissolve faster? We can increase the surface area by crushing it, crumbling, cutting it, or we can just stir it like a barista. Okay, another thing to think about is cold and hot water. So this is very simple. If I put this tea bag in cold water versus hot water, which one will get darker faster? Obviously the hot water. So solubility is the ability of a solvent to dissolve a certain amount of solute. So that is like the fancy science definition. Basically it means that heat, if you put solutes in heat and hot things, it will dissolve faster. That's basically what it's saying. So as you can see here, this is going to be the cold water. The sugar is just sitting there, it's just chilling. It's like, no, I'm just not gonna get out of here. And over here is the hot water. The sugar is like, it's so hot, and it's dissolving. Yeah, so that is basically the what it means when it says that heat increases the solubility. All right, so that's the PPT, and we're gonna go ahead and read a little bit more about it in our textbook. Page 78 and 79, okay? All right, and once again, if you wanna just read it on your own, totally fine. Just stop the video here and just read it on your own. But if you wanna go ahead and read it with me, then go ahead and keep watching the video. So let's get started. Concentration and saturation. So the concentration of a solution is the amount of solute that is dissolved in the solvent. For example, suppose that you mix a powdered fruit drink mix with water. The powder contains flavoring and sweetener. When you mix the powder with water, then the powder is the solute and the water is the solvent. By altering the amount of solute, the concentration of your fruit drink can be changed to suit your taste. So if you put a lot of the powdered mix into the water, then the solution will taste really strong and it will be concentrated. So concentrated means that the solvent is holding more than a normal amount of the solute. Concentrated. So right here is concentrated. But if you put just a little of the powdered fruit drink into the water, then the solution will taste weak. It will be diluted. A solution is diluted when there is less than a normal amount of solute in the solvent, right over here. It's a lot lighter, correct? Sometimes the concentration of a solution can be adjusted or changed to make the solution more useful. Often, a cleaner is mixed with water to form a cleaning solution. To wipe the counters and the sinks, you might use a diluted solution with only a weak concentration of cleaner. But if you want to clean a really dirty floor, you would use a lot more concentrated solution, a lot more cleaning products. And if you continue to add more and more solute into the solvent, then the solution will become saturated, which means that the solvent is holding all of the solute that it can dissolve. It cannot hold anymore. The limit has been reached. Now, rate of dissolving. So this is like how quickly can the solute dissolve. Sometimes a solute can take a long time to completely dissolve in a solvent, but there are ways to speed up the process. One way is to increase the surface area of the solute, and this can be done by crushing, crumbling, like this, or cutting it into small pieces. And the more solute that touches the solvent, the faster the solute dissolves. And this is why rock salt dissolves more slowly than a teaspoon of salt does, because it's bigger. So a substance with greater surface area will dissolve more quickly than one with the less surface area. So the crushed sugar takes up a lot more space, right? The surface area is bigger, so it will dissolve faster than these smaller cubes. Another way to speed up the rate of dissolving is to stir the solution. Stirring brings more fresh solvent into contact with the solute. It helps spread the solute faster. Perhaps you've seen someone sweeten coffee with sugar. Usually, he does not just put the sugar in the coffee, he also stirs the coffee. This causes the sugar to dissolve more quickly. Temperature also affects how fast the solute can dissolve. This is because heat increases solubility. And solubility is the ability of a solvent to dissolve a certain amount of solute. The particles in a heated solvent move faster than when the solvent is cooler. So this increases the rate of contact with the solute and speeds up the dissolving process. Faster moving molecules also spread farther apart. That leaves more room for the particles of the added solute to dissolve. Suppose that you want to add sugar to tea. The sugar will dissolve more quickly if the tea is hot. The sugar does not dissolve as easily in cold tea. Instead, the sugar tends to kind of settle to the bottom of the glass instead of dissolving. Using matter. Often our love is shown by what we do with physical objects. You have learned about matter and some of its properties, but there's much more to learn about matter and how it works. Jesus said that the second great commandment is to love your neighbor as yourself, Matthew chapter 22, verse 39. Measuring and mixing matter can help you obey that command, even if it is by baking brownies. My mom actually baked brownies yesterday. Quick check. All right, so we're going to go ahead and stop here, and we will be answering the questions in our next video. Great job. Great concentration. And I will see you again very soon.